Good day everyone. We are back again with algebraic models. This time we are going to do something that is directly connected with the one we saw last time. The one that we saw last time was that for a plus b whole raised to 3. And the model looks something like this. This is what the model looked like. And now a step further, can we have something for a minus b bracket raised to 3? Sure. Not only that, but as in the case of a plus b whole square, if you recall, and I am sure you do, we had a plus b whole square, the same model we had used for verification of the identity for a minus b whole square. And what we had done was, the basic difference was that instead of taking a and b, we had taken the whole as a and a part as b. And the second thing was that we could not straight away see the identity. We had to remove something, then add something, and then remove something. So that's precisely what we are going to do here. What we'll do is, first of all, as you all know, the identity is a minus b whole cube is equal to a cube minus 3a square b plus 3a square b minus b cube. This is our identity. And as we have seen and decided already, as in the case of a plus b bracket square, here also we are going to take, because there is minus, we shall take the whole as the bigger one is a. So we shall take this entire length here as a. And what will be our b? A part of it, either this or this. What we will do is, this part is seen here, we know this is a little cube. What we will do is, the whole length is a, this little black length we shall call b. And so what we will have now is, this is a, all the way on all sides. Then this is b. We don't know anything about this length now, remember that. We don't know anything. We do know it is a minus b, but that will not help us in removing and adding. But we'll do something about it. Well, alright, with this much in the background, we start. What shall we do? We shall do this. First, let us see what we have here. They are the same pieces, but the lengths are different now. Formerly this used to be a, now this is not a, but there are 3 pieces, 3 cuboids of the same size. These 3 cuboids of the same size and 2 cubes. And we have them arranged to form a cube whose whole side is a and the little side is b. The black side is b. Okay. What have we to do now? Let us see, we want a minus b and the cube of it. We want the cube, so it has to be one of the 2 cubes, either the black one or the red one. The black one is b. So this is the only way. Let us check whether its length is a minus b, the whole is a, this is b. So that's nice. The red cube is a minus b length side, and therefore its volume will be a minus b whole raised to 3. Or in other words, this, what we are looking for, is nothing else but the red cube. So what we have to do now is that we have the A cube, remove everything so as to keep only the red cube. And whatever we do will give us the red cube. So we'll find out what we have done. Okay, we are starting with A cube y, that's what we have. The whole entire big length is A and we have a cube of length A. Now, if I want to remove something, and we have to remove, except this red cube, everything has to be removed. We know the length of only one thing, dimensions, and it is this. So we know the volume of only this one, and that is B cube. What about the others? I can't say that I want to remove this. What is this? I don't know. I don't know this one. But we'll make a note before we start that there are some pieces when combined we can get the volume, as we had in the square thing. And that is, suppose I take only this much, or rather two of them, not just one. Then you know that the whole length was A, this length is B, and the base is B square. So this is B square A. This is a cuboid whose volume is B square A. Okay? We don't know anything about any of these independently or together. We know that this is A, but we don't know about this length here. So what we do is we put it together like this, as we had here. Now we know that it was nothing else but this. What was this? A. So that is, this area is A square. And in fact, this is a cuboid whose base is A square, touching my hand, and the height is B. As you can see, the height is B. So this is A square B. And we are going to take them all four together and take them out. So what have we taken out? A square B. We have taken out means minus. Okay. Now we have some idea, we have got the grip of the situation. Now we want to remove this part. Once again the same problem. Well, not quite. Add this much. And then you know that we'll get exactly the four pieces, 2 green, pink and black. We know that is A square B. Now we have to add this. So I note down what we are adding. How much is this? We have seen this is A, B square. I'm sorry. I repeated this here. This is A square B and this is AB square. And I was wondering how I got it. I should have AB square, and how did I get A square? Well, okay. So I have AB square and I'm adding it, so I will put a plus. Now what I can do is take away the whole. And when I take away the whole, I know it is A square into B. So it is, oh God, I'm taking away, I had taken away only one A square B and I wrote 3 because I saw 3 there. So I first took away the A square B, added AB square, and then again I am taking away A square B. Now only one piece remains to be taken. I will put it this way. Only one piece remains to be taken away, but we know we can't do anything with it. We can add this at most. Okay, let's add. What are we adding? AB square. But we still need a piece here, so that we can take away all 4, and we don't have it. And we can have it only with this. This cannot go alone. But this has been used up. Okay, take it away. Why? Because we want it. Take away means what? Minus. What are we taking away? Whose volume is V cube. And now I have what I wanted, AB square. I put it here. So now I have added AB square. And now I am ready to remove all the four pieces together. And they are A square. Alright, after all this taking away and adding and all that, what are we left with? Exactly what we wanted, the red cube. And the red cube is A minus B whole cube. That means that at the end of all this, what we get, the volume that we get, we start with the whole big A cube, remove something, add something, keep on changing the volume. Ultimately the volume left is this, and it is this. That means that these two are equal. But these two are equal means what is this? Let's see what it is. It is A cube minus 1, 2, 3A square B plus 3AB square minus B2. Well, that's precisely our right hand side. Or in other words, what we have done is, we have verified that A minus B whole cube is A cube minus 3A square B plus 3AB square minus B cube. And that takes care of the identity and its verification. Now the question would naturally arise, what about the model? In fact, we have not made the model for A plus B whole cube also. And once we make one, it's going to work for both. What we are going to do is that the 3D models have a same technique. There are many other 3D models which we come across in school. They have the same technique to start with. So we'll take them all together in one session. So that will be for the making of the model. Right now we should be satisfied with this. Thank you.